A couple of problems to go. This is not going to take the whole time. I couldn't film the previous video. At noon, a ship west. So they're talking about navigation. Alright. At noon, ship A is 150 kilometers west of B. So, at noon, ship A is 150 kilometers west of B. Ship A sails east at a rate of, so call this X, at a rate of 35 kilometers per hour. Ship B sails north, call that Y, at a rate of 25 kilometers per hour. How fast is the distance between the ships changing at that time? So, as ship A gets closer, and this is going further, that's the distance between them. Right? So, if I need to find an equation for this triangle, there's the distance between them. That right there is Y. And that right there, since it was 150, that right there is 150 minus X. True? And if I use the Pythagorean theory, it says, the theorem theory, d squared equal y squared plus 150 minus x squared. There it is. And if I take a derivative of this, well, let's see, 2d, the change in distance with respect to time, is 2y, the change of y with respect to time, plus 2 into 150 minus x squared, the change of x with respect to with respect to time. But that's a negative. Right? The derivative of the inside is a negative 1. So, twice the distance I'll get in a minute, the change of the distance between them, I'll get that in a minute. Actually, I could drop that 2 off. Y I have, I'll get in a minute. dy dt I have as 25, I'll get that in a minute. 150 minus x and a negative, and let's see how this works. I know this is 25, and I do know that this is 35. What's missing? This was at noon. At noon we were at those distances. By 4 o'clock, 4 hours. 4 hours. X is moving at 35 kilometers per hour. Times 4, that's 140. Right? 140. And this is 150. So basically, I could say this is 10. That's simple. If this passed 140, now it's 10. This is moving at 25 kilometers per hour. In 4 hours, that moved 100. So do you see why I need this triangle? If this is 100 and this is 10, I still need to find D. What is D? D is the square root of 10 squared plus 100 squared. 10,001. And dd, the change of the distance between them with respect to time, is what I'm looking for. So I could multiply that out. That's 2,500, right? And this is 10 minus 350 divided by the square root of 10,000, and you know what? You have a calculator. What are the units? Distance takes linear units with respect to hours. And there it is. Number 18. A spotlight on the ground shines on a wall 12 meters away. Let's say the spotlight is right here, and this is the wall, and this is 12 meters. If a man 2 meters tall walks from the spotlight towards the building at a rate of 1.6 meters per second. Well, let's say this is x. Then we know that the x dt is 1.6 meters per second. How fast is the shadow? Well, the shadow is going to look something like this. As he's walking away, this shadow is shrinking, right? Assume this is S. How fast is the shadow on the building decreasing when he is 4 meters from the building? When he is 4 meters from the building, this distance is 12 minus x. When he's 4 meters, that means when x equal 8, if he's 4 meters away from the building, that means he really walked 8 meters, because altogether it's 12. Now, what's the tough part here? I need an equation to combine those. This is one triangle, and this is a similar triangle. So, I could say the entire side, which is 12, well, maybe backwards would be better. Yeah. S to 12 should equal 2 to x. And if I cross multiply and do my magic, that's really 24 over x, or 24 x to the negative 1 if I really don't want to use the quotient rule. And if I take a derivative with respect to t, so this is how you could avoid the quotient rule. Bring the power down, subtract 1 from the power, dx dt. So basically what we're getting, ds dt equals negative 24 over x squared dx dt. And the change of the shadow is negative 24. We said x was 8, and the x dt was 1.6. What would be the units for a shadow? That would be in, meters per second. So we're going to stop here for this video. I'm going to finish this up in the next lecture. Let me show you the homework really quick. And there's the homework for now.